So as we had our revisions before, we are going to consider also another exam question, which is important that we do understand. A lot of questions that are very similar to what you might be having in your final exam. So this is from the Gauteng Department of Education, November 2020 exam. So due to some of the topics, remember I talked about this on the topics that you are now having, and we saw that some of the topics is actually been taken out. So I had to consider those topics away. So I just had to consider what is part of our teaching plan according to this year of 2024. So these questions similar to these can be asked. And if you check, it's just one and the same as what we had in those other question papers. So not wasting time, guys, let us quickly rush through our questions and see. On question number 1, we were given to state whether the following are true or false. 1.1, the first three multiples of 20. The first three multiples of 20 are 20, 40, 60. Are these three multiples that we are given the first three multiples of 20? That's true. Remember, 20, that's 20, 40, 60, 80, 100, 120, and so on. Multiples of 20, you multiply by what? By 20. 20 times 1, which is a 20, 20 times 2, which is a 40, like that. 20 times 3, remember I talked about this issue of multiples, 20 times 4, and so on, which is 8. So multiples 20, 40, 60, 8. So the first three that we are supposed to consider, those are exactly the ones that we are given. So this is actually true from what we are given from our information. So you have to consider each part as you are given. On 1.2, you're given the square root of 64 plus 36. Is it greater than the cube root of 27? So guys, you can also use your calculator to simplify this if you do not know this, but you can simplify this 64 plus 36, which is 100. So we've got the square root of 100. Is it greater than the cube root of 27? Remember the square root of 100, that is a 10. So we've got the cube root of 27, which is a 3. So comparing these two, is 10 bigger than 3? Is 10 greater than 3? Yes, 10 is bigger than 3, which is actually true. So from this part, this is actually exactly what we are given from there. Then on 1.3, we are also given that the product of AB, it is equal to BA. Is it true that the product of A and B and the product of BA is the same? This is actually true. Remember your commutative law under a multiplication. That is our commutative law. From a multiplication, if you're multiplying 2 times 3, it is the same as 3 times 2. This is very true. If it is an addition, because they can also ask you that under an addition, if you're given A plus B under the same commutative law, it is equal to what? B plus A. So this is for addition. For multiplication, the product of A and B is equal to the product of what? Of BA. That is our commutative law. So this is important for you to actually know your laws as we are to consider the simplification of our normal numbers. 1.4, the values have been written in descending order. Remember descending order, that is decreasing from the bigger number. Let's say I've got 6, 5, 4, 3, 2, 1, and so on. That is descending, which is opposed by the ascending order. Ascending order, that is the numbers are increasing. So if we are to compare what we are given here, that is we have got a 0, 3, that's a 0, 3, all right, followed by what? So this is 0.3 followed by the cube root of 0.01. So guys, this is just for a 1 mark. So you can even just use your calculator to simplify that square root if you are not used to the simplification, but you can see that the answer there is supposed to be what? 0.1, or you can just use your calculator, the square root of 0.001, so that you have the exact value there. So that is, all right, that's the square root of the cube root. Where am I getting the square root, guys? This is the cube root. So you need shift, and that is this one, the cube root there of 0, that's 0.001 like this, which is 1/10, same as what? 0.1. So from the cube root of that one, we are obtaining a 0.1, so that we actually see what exactly are we having there. Then what about 0.2 raised to the exponent of 3? So we're going to do the same thing, 0.2 raised to the exponent of 3. That is 1/25 as a decimal. That is 0.008. That's 0.008 like this as a decimal. So we can compare now these decimals that we are given. Is it in descending order? Are we given from the bigger decimal? How do you compare a decimal? Remember, decimals, like if you're given a 0 like this, let's just take a scale of 0 to 1, where we have got 0.1, let's say this is 0.1, 0.2, 0.3, 0.4, and so on up to 1. So we can see the bigger the values is the number that we are given, like 1, 2, 3, and so on. If you're given more zeros, like this is very small, 0.008 is something that is in between them. So this is exactly in descending order. This is bigger compared to this, compared to this. It is in descending order. If it is ascending order, it was going to be 0.08, the smaller one, followed by what? 0.1, followed by 0.3. This is ascending order. This is the descending order. This is actually true. That's a descending order that you're given there, from the bigger value to the smaller one. Then in 1.5, we are given that in a normal fraction, C over D, is it less than D over C? Remember, a normal fraction, if you're given C over D is actually a normal, a proper fraction. Maybe we are talking about 3/5. Remember, a proper fraction, the denominator is the one that is what? Big in value compared to the numerator. So can we say it is less than if we interchange and write it as 5/3 with 5 on top? Can we say this is less than to this? No. This one is bigger. 5/3, if we are to check, this is an improper fraction, which is 3 into 5 is going to give us 1 and 2/3. I'm just giving an example to see what is happening. So this is a proper fraction. This is an improper fraction. So an improper fraction is bigger than. An improper fraction is what? Is supposed to be bigger than what we are supposed to have. Like if we are to consider any consideration of a fraction, 3/5, is it going to be less than this? That is exactly what we have. This is big. This is less than, which is actually true. So if we are to consider as an improper fraction now, in terms of an improper, if we start with an improper, but if we say C over D, we take it as a proper fraction. Guys, D over C is going to be an improper fraction. And an improper fraction is what? Is bigger than a proper fraction. Because we have got a whole number. There we cannot even obtain a whole number. It's a fraction that we have. So from this is actually true. If this C is what? If C over D is a proper fraction. So also this is supposed to be specified so that under exam, you guys must understand also how it is given. It must be properly given. If it is given like C over D like that, you have a lot of confusion. So what does C represent? So just put an example there. Then you write your statement. What does it represent from the example that we have what? Indicated. On 1.6, 2 to the exponent of 3 plus 2 to the exponent of 2 is equal to 4 to the exponent of a 5. From which law, from which concept? This is actually wrong. If we are simplifying addition, we do not have a law which govern addition. No, we do not have a law. Addition, you simplify this on its own. 2 to the exponent of 3, you are going to multiply 2 itself to, 3 times. 2 times 2 times 2, 3 times, which is going to give you 8. Plus 2 to the exponent of 2, which is 2 times 2, which is going to give you a 4. You add 8 plus 4, which is a 12. 4 to the exponent of 5 is actually something else. This is not true. This is not. We do not have a law which is used under an addition there. There is no law that can be used there. So that's false there. Let's consider another part, which is, all right, so there we have to be careful because sometimes these memos, guys, the way they present and what is given there, you have to take note of some of these errors. 3x to the exponent of 5 times 4x to the exponent of 2 is equal to this. All right, we are multiplying. It's very true. You're going to multiply this 3 times 4, which is 12. But what is going to happen on x? If you're multiplying the bases which are the same, you add the exponents. It was supposed to be 5 plus 2. You add. So it was supposed to be 12x to the exponent of 5 plus 2, which is a 7, not a 10. It was supposed to be a 7. So this is actually wrong. So that's false. All right. Consider another question. You are given this 3ab raised to the exponent of 2. 3ab raised to the exponent of 2. What does it mean? It means each and every term is going to be raised to that exponent that we see. It is going to be 3 to the exponent of 2. 3 to the exponent of 2. That's 3 times 3, which is 9. Not a 6. It is 9. So it was supposed to be 9. A raised to the exponent of 2. B also raised to the exponent. Everything is going to be raised to the exponent of 2. So take note that 3 squared gives us a 9, not a 6. So this is wrong, which is false. So that is what we had in that case. All right. So you have to be careful in your simplification. On question number 2, for each of the questions, 4 possible answers are given and only one is correct. Select an answer and indicate your choice by writing the corresponding letter in the space provided. 2.1, what is the sum of all factors of 15? What is the sum of all factors, all of the factors of 15? So we just need factors of what? 15. What are the factors of 15? You divide by that, you obtain an exact value. So factors of 15, 1 is a factor of 15, 3 is a factor of 15, 5 is a factor of 15. And also 15 itself is a factor of 15. 15 is a factor also of what? Of 15. So you have to be very careful in that case. So the question is, all these factors that we have listed, what is the sum? The question is on the sum. Sum of all the factors. You have to add sum. You have to add. So we are supposed to add 1 plus 3 plus 5 plus 15. That is that was the case of our question. So in this case, we're just going to add, and that was going to give us a 24. This one 20, 23, 24. So 24, which is on D. So the answer there was going to be what? D. From the sum of the given factors. So like I said, some of these questions, I removed them because of part of your syllabus, this and that, what you're working with. So I'm just going to focus with what you have in this case. The figure below shows the net of a solid. What is the name of the solid? So in this case, we have to consider like if we're to have a complete figure at the end with this triangular part that we have. This is supposed to be what? A triangular prism, not a pyramid, but a prism, which is B. So in this case, we remember now we are working with the 2D, the part of 3D. We're not going to have it. I talked about that. So meaning to say, we're not going to waste much time on the 3D questions. We have to focus much on our 2D perimeter and area. That's our major focus as we had our syllabus now. On 2.4, we are given the grade A's that we have were asked to name their favorite pizza that is topping. The pie chart represents their choices. The same number of people's like vegetarian, chicken on their pizzas. So take note there. They are saying the same number of people's like vegetarian and what? And chicken. Meaning to say this part of chicken and vegetarian, we have got the same number, which is what? 26%, according to what we're given. It's a percentage they gave us as a percentage. Remember, percentage add up to what? 100%. The whole part must give us 100%. They gave us as a percentage. If they give you as degrees, let's say we're given 30 degrees, 40 degrees, that is supposed to be from a complete rotation, which is 360 degrees. But there, they gave us percentage. So you work with what? 100%. So the question was, what percentage of people's like means from what we're given? What is it that we have on the means? This one. So you just have to calculate out of 100%, you remove what you are given. Out of 100%, you are supposed to subtract this because this is a percentage out of what? 100%. We have to subtract all these percentages that we are given. The one for chicken, which is 26. We also have the 33%. We also have another 26%. We subtract all these from 100%. The remainder or part is the one that is representing what? The means in that case. So we have to subtract everything. So that was going to give us 15, which is 15%. So 15%, which is the one that we are having on A there. That is our answer, was going to be on A, where we are given the 15%. Then in question number 3, we are given this part, which is under our number patterns as you consider the issue of the sequences that we have. How many cans will be in fig E and F? In fig E and F. There we are given some of the information that we are having, like this is fig A, this is fig B, this is C. So we are going to have D, E, and so on. So they want us to find what are we going to have in fig E and what and F. So if we consider what is happening here, there is one can, okay? Then we move on here on the base. There are 3 cans that we see, and they reduce 3. They reduce to what? To 2. They reduce to 1. I want you to see what is happening there. We move on to another one. If we count these cans on the bottom part, we'll see that there are 5. And they are reducing. These ones, there are 4. These ones, there are 3. These ones, there are 2. These ones, 1. So you can see that it is just the number on the base. We reduce from that one, 3, 2, 1. If we are given 5, so it is going to be what? 5, 4, 3, 2, 1. We are reducing from the number on the base. So what is important is for you to know the number on the base. Then you simply work from that way to say if you ever got a 5, you're going to simply add 5 plus 4 plus 3 plus 2 plus 1. 3 plus 2 plus 1. So what is important is to know the number on the base. So let's move on to D. What will be the number which is on the bottom, on the base. If the first one here, we only had one can on the base. Then on this one, there are 3. On this one, there are 5. We can simply know the number of cans which are on the base because we can see that this is a linear pattern. Look, the first one we are saying we have got one can on the base. We are talking about on the bottom or on the base. The base is what is important because it gives us the number from there. We know that we're just going to subtract 1, 1, 3, 2, 1, 5, 4, 3, 2, up to 1. So if we know the number which is on the base, we are done. So the first one, it is just 1. The second part, there are 3 cans on the base, on the bottom. On the third part, how many cans? There are 5 cans which we have on the bottom. What is it that is happening about? What is the relationship about these cans that we have on the bottom? We can see that they have a difference of 2. 3 minus 1, that's a 2. 5 minus 3, that's a 2. So we have a difference of 2 from each. So meaning to say, we can find the next one. We can know the number of cans which are on the bottom. We can know the number of cans from there because we know that there's a difference of 2. From one to another, there's a difference of 2. So we just have to add 2. 1 plus 2, that is 3. Plus 2, that is a 5. So 5 plus 2 is what? 7. 7 plus 2, that's a 9. 9 plus 2, that's 11. So these are number of cans which are corresponding on the base. So just like what we had, this is our A, this is our B, this is our C, this is our D, this is our E, this is our F. So the question needs us to find how many cans will be in fig E. The fig E, the one where we have a 9 on the base. Fig F, where we have what? 11. So you're supposed to be careful. It's not D. If they want D, we are supposed to start with this one of a 7. So yeah, we have to be careful, guys. If you are using these question papers and your memos there, sometimes they just write. You have to be careful also as we are revising. So the part of E, this is A, B, C. There's supposed to be D, E, and F. So we are not focusing with the D there. We are focusing with what? With E. So if we are focusing with E and F, what is the scenario, guys? These are the number of cans on the base. So remember, they're reducing. Like 3, 2, 1, 5, 4. We saw that 5, 4, 3, 2, 1. So it is the same thing. 7, 6, 5, 4, 3, 2, 1. So it was the same thing that was going to happen on this 9. It was going to be 9, 8, 7, 6, 5, 4, 3, 2, up to 1. So these are the numbers. These are the numbers that you're adding, just like what we saw. If you want to see this number of cans that are here, we are simply adding 5 plus 4 plus 3 plus 2 plus 1. You are adding. But are you seeing that these numbers are reducing? 5, 4, 3, 2, 1. So it is the same thing. If it is even on this 9, it is going to be 9, 8, 7, 6, 5, and so on. So in that case, if they are saying E and F, we have to focus where E is and where our F is. And the part of F from 10 up to what? Up to 1. From this 11 up to 1. So it's going to be 10, 9, 8, 7, 6, 5, 4. That will be 3, 2, 1. These are the numbers that you have. These are the numbers that you are supposed to add. So you have to add these numbers: 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. You add. So that was going to give us a 45. You do the same thing. From there, you add this one, 10, this 11 plus up to the end, up to 1. You add all those numbers that you are given. And that was going to give us 66. So these ones were going to be 66. So that's 45 and 66. You're supposed to also be careful. Like I said, your memo, guys, you're supposed to be very, very careful. Or sometimes they want to ask a certain question, but they'll be writing another way. So this is 66. Unless if the question was, how many cans will be in fig D and E, because we can see that we ended up at C. So D, it's a continuation, D and E. We are going to take that one continuing from the D, this one, D and E. And for D, you add up to these numbers, it was going to be 28 and 45 if it is D and E. But this one is E and F. So guys, be careful with your questions there, your memo as you are revising. 3.2. How many rows are there in A, B, and C? In this A, B, and C. How many rows? Like this is a row. A row is like this. That's a row. So in the first one, how many rows? We just have one row. We move on to B. How many rows? This one is a row. That is 1, 2, 3. There are 3 rows. In this case, how many rows? 1, 2, 3, 4, 5. There are 5 rows that we are having. So you can simply see the number on the base is representing the number of rows that we are having, like how many rows that we have on that particular part of can that you're given. Then on this part, 3.3, how many cans will be in the nth row? Remember here you have the pattern here. It's now a pattern that you have there. You have it in terms of the rows 1, 3, 5. You already have it 1, 3, 5. This is the part of the rows. So they want you to have that the nth row. What is going to represent the nth row? So guys, I talked about this from your patterns that this is going to be given as Tn is equal to the difference. This is a linear where we consider the first term, the second term, the third term, the difference, second term minus the first term. So if you subtract T2 minus T1, that is 3 minus 1 is going to give us a 2. You do the same thing, T3 minus T2, you subtract T3 minus T2, that is 5 minus 3, which is going to give us a 2. There is a same difference of 2 there. So Tn is equal to 2n. Tn is equal to 2n plus what? Plus C, where you need to find the value of C. So the C is the one that you can simply find in this way to say this is the first term, which is 1. Like T1 is equal to 1. The second one is equal to 3. T2 is equal to 3. The third one. So you can write, we can substitute like in place of our Tn, in place of Tn, we substitute a 1 is equal to, in place of n, remember this is Tn. So n is equal to what? N is equal to 1. So it's 2 times 1 plus C. You can use any part. You can use this one. This is T2, which means 3 is equal to 2 times, n is represented by what? By 2. So it will be 2 times 2 plus what? Plus C. Then you have to find the value of what? You have to find the value of C from there. Any part that you have there, guys. Any part. So we used the first one. We used the T1, which is equal to 1. So it's 1. In place of n, you substitute 1. So 2 times 1, that's 2. Then we subtract 1 minus 2, guys, was going to give us minus 1. If we take the 2 to the other side, it will be a minus. That's 1 minus 2, which is a minus 1, which is equal to what? To C. So that is the value of C, meaning to say, therefore, our Tn was equal to what? 2n plus C, which is plus what? Minus 1. So that is simply a minus 1. Remember, plus and a minus like this will give us what? A minus at the end. So this is the Tn that they want you to write for this nth row that you are going to have. So it is Tn that we have, which is equal to 2n minus 1. So it can be used to simplify anything that we have on the rows, the number that we have on the row, like the rows that you're going to have, or the numbers that we have on the base. So on 3.4, how does the number of rows relate to the number of cans in the base or the bottom? How does it relate? This is what I was explaining before to say, if we see properly, The number of rows that we have, this is the number of cans that we have on the bottom. We have 3 rows. How many cans are we having on the bottom? 1, 2, 3. We have got 5 rows. We have got 5 rows, like in terms of the rows with that we counted. How many cans do we have on the bottom? There are 5 cans. So the number of rows, this one, is equal to the number of cans that are there on the base. It is exactly the same. If you consider the first row, there was 1 can. So we are simply saying the number of what? The number of rows is equal to the number of what? To the number of cans. This is the number of cans in the base, which is in the what? In the bottom. Those cans, they are equivalent to the numbers that we have as the number of rows. On question number 4, it was to simplify, as we can see there, our exponents, part of our exponents that we need to apply. 4.1, a to the exponent of 3 times a. Remember, same basis. If you're multiplying, we are simply going to add the exponents 3 plus 1, which is going to give us a to the exponent of 4. That is, we are considering what? The bases that are the same. We add the what? The exponents. So that is what we have. So in this case, I don't know what happened. Is it my question paper that just, I don't know if we had a 2 on the original question paper. So if you have a 2, then you are simply going to add a to the exponent of 3 plus 2, which is going to be a to the exponent of 5. So that is, we just have to work with what you're given there. You have to add exponents. Exponents, if you're given a 1, you add the exponents 3 plus 1, which is a 4. So you have to be careful with your simplification. 4.2 x to the exponent of 3 plus 1, it's in a bracket and everything is raised to the exponent of a 0. So that's going to give us a 1. Okay, any number raised to the exponent of a 0. If it is a bracket, 3x squared plus whatever that we are given, maybe it's 3y raised, as long it's a bracket, everything will be equal to what? Will be equal to what? So we have to be careful. On 4.3, we can use our laws, or we can simply divide the x to the exponent of 3 over x to the exponent of a 5. The bases are the same. Remember, if you're dividing, you subtract the exponents. So it is going to be 3 minus 5. That is x to the exponent of a minus 2. And we understand that if we are given x to the exponent of minus n, that is 1 over x to the exponent of n. We remove the exponent by 1 over. So that's 1 over x to the exponent of a 2. Or you can simply divide. When you're given this type of equation, guys, you can simply divide like this is x to the exponent of 3 over x to the exponent of 5. You're simply asking yourself, these are x's. How many are they? There are 3. Here there are 5. So if we divide 3, these ones, into these ones, which are 5, how many x's are we going to remain with here? We are going to remain with the 2 x's. So it is going to be 1 over x squared. This is the same situation or the same scenario that you can actually evaluate on this type of a question if you understand that. To say that you can simply reduce these numbers. So as you can see, you can reduce them. We can see that the 2 here, 2 into 2, that is 1, into 12. 12 divided by 2 is what? That's a 6. Then the part of the x that we are given, all right, there are 3 x's here, x to the exponent of 3. There are 3 of them. We cancel 3 into these ones, which are 6. How many are we going to remain with? We are going to remain with the 3 x's. But there's another x there. There's another x, the x squared. There are 2 of them. 2x squared, it means 2. So we cancel 2 into these ones, which are 3. How many are we going to remain with? We remain with 1x. So in that case, we can even divide that way. You understand that way? The part of why you can also do the same thing. Okay, in terms of the numbers, we have to reduce again. The 3 into 3, that is a 1. The 3 into 6, that is a 2. You reduce by 3. You divide 6, divide by 3. That's a 2. The part of y here, It is y that we have into this one. How many are we having there? It was y cubed. There were 3. So we are going to remain with the 2 of them, y squared. We still have a y here. This y and this y cancels. We're going to have a y there. So as we can see, on top, on the numerator, nothing is remaining. We just have a 1. So it is going to be given as 1 over what? In the denominator, there is 2x and y. So we are going to write as what? As 2xy. You can actually do that way. If you understand this, guys, you can actually have it simplify that way. Or we can apply our laws where our laws are given. There we are just multiplying the numbers, the numerator together. 2 and 3, that is 6. The part of x, there is x here, there is also x. The bases are the same. What do we do if we're multiplying? We add the exponents. So 3 and 2, we add the exponents. That is going to be x to the exponent of what? A 5. The part of y there's a y and a y, so we multiply y times y, that is going to give us y squared. Everything over what? That's 12x to the exponent of 6, y to the exponent of 3. So at this stage, you can even use your laws of exponent, or you can even reduce, like as you can see, this is direct. The 6 can divide 6 into 6, 1. We divide 12, divide by 6, that's a 2. In terms of the x, there are 5 here. X to the exponent of it means there are 5. Here there are 6. So if we divide these ones, which are 5, into these ones, which are 6, how many are we going to remain with? We are going to remain with only 1x. Here, the y's that we have, there are 2. Here, the y's that we have, there are 3. So we cancel these ones, 2, into these ones, which are 3. How many are we going to remain with? We remain with 1y there. So on top, we are just going to remain with 1 over the denominator. It is what? 2xy. As we can see, that's the same answer. There's so many ways that you can actually simplify this type of a question. You just have to be careful with the simplification that you're given. On 4.5, you're given p divided by p. A p over a p, that's a 1. It's just like 2 over 2. It is a 1. The number, if it divided to the same number, it is going to give us a 1. All right, 4.6, the square root of 25. We know this one, it is 5. What about the square root of y to the exponent of 16? How do you remove a square root? Remember, inside the square root here, there's a 2 there. So it is same as y to the exponent of 16 raised to the exponent of a half. That's the square root means to the exponent of a half. So thus you are multiplying. Remember, an exponent, when it meets another exponent, you multiply. So 16 times 1 over 2 is what? Is 8. So that's y to the exponent of 8. Or to remove the square root, if you are given an exponent like this, to remove a square root, you simply divide the exponent that you are given, 16, by the number that is inside of the square root. Like I said, under a square root, there's a 2 there, which is invisible. There's a 2 there. So it's same as what? 2. So that's y to the exponent of what? 16 divided by 2, which is 8. So as you can see, that's the same thing. So you can remove a square root using that way. On 4.7, you are to consider this. All right, so there we have got 3d to the exponent of 5, then e, f to the exponent of 3 raised to the exponent of a 3. Every term is going to be affected by this exponent of 3. Every term 3 is going to be raised to the exponent of 3. The d everything is going to be raised to the exponent of 3. So it is going to be 3 to the exponent of 3, d to the exponent of 5 raised to the exponent of 3. E is 1, so it's e to the exponent of 1 times 3. So it is just e to the exponent of 1 to the exponent of 3. The f is also going to be raised to the exponent of 3. Everything. Whatever that we are going to have there is going to be multiplied to 9d to the exponent of 8. E, this is same as to the exponent of 1. F to the exponent of 4. G is same as to the exponent of a 1. So let's raise 3 to the exponent of 3. That is 3 times 3 times 3 times 3 times 3 times 3. 3 times 3, 9 times 3, which is 27. An exponent to an exponent, how do you simplify? You multiply. So that's 5 times 3. 5 times 3, which is d to the exponent of 15. The part of e you multiply again, 1 times 3. That is e to the exponent of 3. 3 times 3 again, exponent, that's f to the exponent of a 9. Whatever that you are obtaining, you multiply to the remaining part. 9, d to the exponent of 8, e to the exponent of 1, f, g to the exponent of a 1. Where we are multiplying the numbers, we can simply multiply them direct. 27 times 9, what is the product? That's 243. Then now you have to consider the bases. This is D, this is D. The bases are the same. What is that you do? You add the exponents. 15 and what? And 8. You add exponents. So 15 plus 8 was going to give us what? A 23. So that's D to the exponent of 23. We do the same thing. The part of E, we can see that we have got an E, and we also have E. We add e to the exponent of 3. We add the other one, the exponent, which is 1. So that's e to the exponent of what? E to the exponent of a 4. You consider the part of f. There is f here. There's also f. You're multiplying there. So you have to add the exponents. So that's 9. And this one is a 4. So 9 plus a 4. That's f to the exponent of what? F to the exponent of a 13. All right. So that is, all right. Did we add here? This is E, guys. This is E. We have got E that we have. All right. This was 3. And this E is a 1. So just have 3 plus 1, which is 4. All right. Then the F we added, that was 13. So that's F to the exponent of 13. Then the G is on its own. That is G to the exponent of 1, as it is like that. So that is what we had. So you have to be careful. There, the E is not raised. It is just on its own. So it is E to the exponent of 1. Right? This one, it is E, which is on its own. So it is going to be 2. There, that is 1 times 2, which is a 2. I don't know what happened with my question. I think the original question was supposed to be having a 2. Or it was just a 1. I don't know what happened with my question. It was like this. So you know this, guys, but if it is like this, then it is going to be e to the exponent of a 4. Also check your question paper, guys, the way that it's written, how it is presented there on this e there. All right. If it is just e like that, then our answer is going to remain like what we have. On 4.8, we also have a part to simplify. So there we have got 3x. This is just a product. 3x squared times 10. So 3 times 10, that's a 30. So that's 30. X squared, y to the exponent of 3 over 12x, y to the exponent of a 4. So we can reduce these numbers, 30 and 12. The bigger number that we can use between 30 and 12 is a 6. So we can reduce by a 6. We can divide by a 6. 30 divided by a 6, that is a 5. 12 divided by a 6, that is going to give us a 2. So we can reduce this one by a 6. Then in place of x, we can see there is only one x here. Here there are 2 of them. So if we reduce this one into these ones, which are many, these ones which are 2, how many x's are we going to remain with on top? We are going to remain with 1x. For the y there, we have got these ones which are 3 and these ones which are 4. So if we divide these ones, 3, into these ones, which are 4, how many y are we going to remain with? How many y's are we going to have? It is going to be 1 y that we are going to remain with. So that is 5 times x, which is 5x over 2 times y there, which is what? Which is 2y. Just like that. So in your mathematics, guys, you just have to be careful the questions that you are given. Then on question 5, consider the expression a law when answering questions that follow. 5.1, simplify the above expression. And write your answer in descending powers of x. Descending, that is, you are supposed to be reducing these in terms of x. So we are given this, we just have to consider the exponents, guys, where we've got an exponent of a 3. The higher exponent that we can see is exponent of 3. There we also have an exponent of 3. There we also have an exponent of 3. So these are the like terms. So that's 7 minus 2 minus 1. There is a 1 there. So it's 7 minus 2 minus 1. So what are we going to have at the end? That's 5 minus 1, which is 4. So that was going to give us 4x to the exponent of 3. We move on to the squared. Remember, in descending order, in powers of x, we start with 3. We go to 2. So in terms of 2, there is minus 2x squared. There is plus 6x squared. This is the part where we have what? The exponent of 2. So the numbers minus 2 plus 6. Minus 2 plus 6, that's what? That's 4. So it is going to be plus 4x squared. Remember, there is x squared there. Then we move on to the part of x. Where x is, there we have got minus x plus 2x. Minus x plus 2x. This is the same as minus 1 plus 2x, which is what? Which is x. So that is plus 1, which is same as what? As plus x. Then the constant at the end, which is what? A 7 plus 7. So that is in descending powers. We start with 3, 2, 1, up to the constant, where we have this as x to the exponent of 0. Remember, this is 1. So it's like 0, 1, and so on. So they were decreasing 3, 2, 1, up to 0. So that is the descending powers of x. Then from that expression, write down the constant term. We can see the constant that we have is what? Is a 7, where we do not have x. Then 5.3, they want you to evaluate the expression if x is equal to minus 1. Wherever x, so instead of you substituting here where there are so many terms, substitute on this expression here that you have simplified. Where we have x, we have to put minus 1. So it's 4 into minus 1 to the exponent of 3 plus 4 into minus 1 raised to the exponent of 2 plus, in place of x, you substitute a minus 1 plus a 7. So there it is just a matter of you and your calculator. You can simplify that direct on your calculator. It is most important that you also understand your simplification of your calculator. All right. Sorry for this, guys. I just hope it is not going to affect us. All right. As I try to share this, guys, you saw that it's not going to give us exactly what I want there. But if you were to simplify properly there on your calculator, you were going to obtain a positive 6. This was going to be a negative. That's a negative 4 plus, this was going to be a positive 4. Then we've got minus 1 plus 7, which was going to give us a positive 6. Or like I say, just use your calculator at once. On question number 6, solve the following equations. 6.1, we are given 72 is equal to 6 into this bracket. Yes, we can expand the brackets by distributing by the 6. 72 is equal to 6 times x, which is 6x. 6 times 1, which is a positive 6. You want to solve for x, you have expanded the brackets, you collect the terms, like terms, 6 crosses the equal sign, it becomes a negative there. So that's why we've got 72 minus 6, which is equal to 6x. 72 minus 6, that was going to give you 66, which is equal to 6x, which is a product. How do you get rid of the 6 under a product? You divide by 6 both sides. So that was going to give us the value of x. 6 into 66, it was going to give us 11. So you can distribute that 6. Or we could have just ignored that distributing of these 6 by dividing by that 6, because it's a product. A bracket means you're multiplying, remember. If you are given a bracket, it means you're multiplying. So the same way that you remove a multiplication by dividing, you can also divide by this 6. Meaning you say you're going to have a 1, 6 into this 72, that's 72 divided by 6. That's a 12, which is equal to what? 1 times any number, it remains as it is. So 1 times x is x, 1 times 1 is 1. You want to calculate the value of x, transpose or take this 1 to the other side of the equation. It will be a minus there. So 12 minus 1 is equal to x. So what is the value of x? 12 minus 1, that is 11. So as you can see, guys, so many ways that you can actually use to solve these equations. 6.2, another equation that we were given. All right, so guys, according to this question, it was actually supposed to be 2x. So this question, guys, I don't know, in terms of re-saving, when I was saving this, it has affected some of my calculation. It was supposed to be 2x there. According to the original question, it was supposed to be 2x over 3 minus 1 is equal to 15. So if we are given that way, 2x over 3 minus 1 is equal to 15, the minus 1, it is not affecting that much. So let us just transpose, take it to the other side. It becomes a plus there. So meaning to say 2x over 3 was going to be 15 plus 1, which is 16. 16 is a whole number, which can be written as a fraction as over 1. Meaning to say it allows us now to cross multiply because we only have 2 fractions, one on the left side, another fraction on the right side. Cross multiplication is possible on this way. So we multiply 1 times 2x, that is 2x is equal to 3 times 16, which is 48. You want to find x and it is affected by 2, simply divide by that 2 both sides. You are going to obtain the value of x, which was going to give us 2, 4, which is 24. So many ways that you can actually use to solve or evaluate whatever that you're given. All right, this was a question. It was supposed to be given. That's 2x. It was 2 to the exponent of x. So guys, I want us to correct this. It was 2 to the exponent of x, 2 to the exponent of 5. So this question was supposed to be like this. 2 to the exponent of x over 3 is equal to 2 to the exponent of 5 over 3. So using the idea of knowing these guys that the denominators are the same, you look into this properly. There's a 3 here. They're the same. So you can even cancel this. In the numerator, we can also see that the bases are the same. The 2 and the 2, these bases are the same. So automatically, as we can say, these 2 also are the same. X is equal to what? X is equal to 5 automatically. Everything that we have is the same. So the exponents automatically will be the same. 6.4, that was the cube root of x, which is equal to 2. How do you remove the cube root? The number there inside the root is 3. By raising to the exponent of that number, which is 3, you raise to the exponent of 3. Also, you must raise this to the exponent of 3. What you do on the left-hand side must be done on the right-hand side. So raising to the exponent of 3 or to the power of 3, it is because we want to remove what? The cube root that we see. So it is going to give us x equal to 2 to the exponent of 3. 2 times 2 times 3 times. It is going to give us what? 8. Just like that. So as we can see, guys, it's just 1 mark. Just raised to the exponent of 3. You are done with that exponent that you are given. On question number 7, which is also important for us to note, it was given, fill in the values in the boxes. So we've got this part that we need to fill in. So considering the first part here, it is from an input on 7.1. We are given an input. Remember, this is your input. Then we have got the rule that we are given, and we have got our output. So we have the input. We just have to substitute in place of x so that we have the output. So the output, 4 minus x, we substitute our x. What is our x? The input. That is minus 2. So minus, that's a plus. 4 plus 2, which was going to give us what? A 6. So the output there was going to be a 6. On 7.2, we are given the output this time, and you have to calculate the input. Remember the input, these are the x values. Output, these are y values. So this time we are given the output. Like we have that output, x squared plus 1, it is equal to 5. We already have that output. It is 5. So what is the x value that was being inserted here so that our output will be a 5? It's an equation that you need to solve. How can we solve this type of an equation? Take the 1 to the other side, it becomes a minus there. It was a positive, remember? So x squared is 5 minus 1, which is a 4. How do you remove a square? A square, the power is 2. The opposite, the square root. Introduce the square root. So thus our x was going to be the square root of 4, which is what? 2. As we know that square root of any number is plus or minus. So we cannot use the minus 2. We already have that one. Sorry, this is another question, but in terms of your simplification, guys, of your level there, they want you to have the positive value. So your x, which is the input, was going to be 2. If you put a 2 here, your answer at the output, truly it is going to be a 5. So that is what it means. On 7.3, what are we having? The input is given 0.1. So we just have to substitute to obtain the output from the rule that we are given, 10 divided by x. So y is equal to 10 divided, what is our x? 0.1. Guys, this is 1 mark. Use your calculator. Do not even waste much time. You're going to obtain 100 from there. That is what the output. So questions can be like that. On question number 8, we are given that Joe plotted the equation y is equal to 4x plus 18 by using substitution and a table. He was substituting these values into this rule, and this is what he got. And this is what he plotted. 8.1. How can we tell he did something wrong just by looking at the graph? How can we tell? Not to say by looking into the table, no, by looking into this graph. How can we tell that something is wrong there? We understand that this is a linear function. We are supposed to have a straight line. If points are being joined, we are supposed to obtain a straight line. But in this case, we cannot have a straight line. Look, there's another point that is remaining. So there's a point there that is remaining. We cannot produce a straight line. It is going to be like this, a zigzag now, which is not a straight line. So meaning to say there is a mistake there, because we are supposed to form a straight line. So this is wrong because it cannot form a straight line. Cannot form a straight line when joined, when these points are joined. Cannot form a straight line when the points are joined. When the points are joined. We cannot form a straight line if these points are actually joined. So that is, he made a mistake. Then now they're telling you that Joe actually has made mistakes. They're saying that in the table and on the graph also, locate and correct them by filling the table below and by plotting and connecting correct points to recreate the graph on the Cartesian plane provided. With this information, they are saying, correct him now. You are the one who is supposed to correct him. Since you said he's wrong, correct him. Remember, this is the rule that Joe was supposed to be using in this simplification. So they gave you a table. Remember, your rule is y is equal to 4x plus 18. So from this rule, how are we going to obtain? We have to substitute the x values we already have. We are given our x values. So y is equal to what? We start with the first one. Our x is minus 5 plus 18. We simplify. 4 times minus 5, that is going to be minus 20 plus 18, which is going to give us a negative 2. We do the same thing. So this one, you can just write this, then use your calculator there. It's just 1 mark, guys. The same thing if this is minus 4. So it's 4 times our x being minus 4 plus 18. You multiply 4 times minus 4, that's minus 16 plus 18. Same as 18 minus 16, which is a 2. You do the same thing when this is a minus 3. In place of this, you're going to substitute a minus 3. So what are you going to have at the end? This was going to give us a minus 12 plus 18. 18 minus 12 is what? It's 6. So this is the correct table that he was supposed to use. And with the table now, they want you to present the straight line which you are supposed to draw. As you can see, this is minus 5. So this line here was supposed to be somewhere here so that it's properly like 1, 2, 3, 4, 5. So this was supposed to be here. This line. All right. It was supposed to be there, guys. It's just wrongly presented. Let us just try to have this line. I just hope it is going to help us. All right. So like this, it was supposed to be here. Like this. All right. So this is negative 5. So you're just going to have like 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. So in terms of this, as you can see, there's a 10 there. And the difference is 1, 2, 3, 4, 5. So what happened in order for us to obtain a 10? It was written as what? 2, 4, 6, 8, 10. Minus 2, minus 4, minus 6, minus 8, minus 10. This is how it was supposed to be. You have being presented. So that is our line up to the 10 there, which is representing the y-axis, and this is your x-axis. All right. So let's mark our point. Minus 5, minus 2. X is minus 5. And y is minus 2. So minus 5 and minus 2, they meet at this point. That is where we are going to mark our point. Minus 5, minus 2. Minus 4 versus 2. X is minus 4, y there is 2. Where they meet, like I said, this one, they meet here. That's where you mark your point. So you go straight. At x, x is minus 4 straight. This is your x. This is your y value. Where they meet, take this one going up, you take this one going this side, they meet here. Where they meet is where you are going to mark a point, minus 4 versus 2. Minus 3 versus 6. Minus 3 here and the positive 6. So this is positive 6 going there. This one going up like this. They meet at this point. Where they meet, you are going to mark a point like that. So using these points that we are given, that we have indicated, we are just going to join them by joining these ones. That is the line now can be what can be formed. So as you can see, a continuous line can be obtained. This is the line that we can end up with of y is equal to 4x plus what? Plus 8. But previously, according to the information that Joe had, the graph was not going to work. So what was the effect? It was the effect, it was here on this point. This one was fine, this one was fine, but this point of -2 was wrong. So you have to be very careful. They want you to correct a certain question using your understanding of these straight lines. So it's like someone wrote a certain part, then you are the one who is supposed to correct from what is being written from there. On question number 10, calculate the values of the variables marked with the small letters A to D. Write your answers, all right? Then show all your calculations. On 8.1, on 10.1, we are given, that's a right angle. This one, it represents a right angle. Remember, that's 90 degrees. This is a straight line. So how can we find A angles on a straight line? So from 180, we are going to subtract the 90 degrees. We also subtract the 20 degrees. So that was going to give us 70 degrees, or simply, we can write it that way, 180 minus 90 and what? And 20 together added like this in a bracket. If you put a bracket like that, still you're going to obtain what? 70 degrees. The reason that we are referring, these are angles on a straight line. So I'm just going to write in short, guys, angles on a straight line. Angles on a straight line. That is what we have. They add up to 180 degrees. On 10.2, we are given this is B and this is also B. And there is an exterior angle, which is 130 degrees. Remember, the sum of these two, B and B, is supposed to be equal to 180 degrees, which is the exterior angle. We are referring to the exterior angles, the exterior angle of what? Of a triangle. I'm just going to write in short. Exterior angle of a triangle is equal to the sum of these two opposite interior. So B and B, it means these two are the same. So we just have to add 1 and 1. 1 plus 1, that is 2B, is equal to 130 degrees. Dividing by 2, that's obtaining the value of B. 130 divided by 2, it was going to give you 65 degrees. So we are referring to the exterior angles of what? Of a triangle, equal to the sum of the opposite interior. So that's our 10.2, 10.3. We are given this diagram. We need to calculate these letters, C, and there's also D. These lines, they are parallel. So look what you're forming here. This is a C. Co-interior angles, where we form a C or it's a U like this. These are co-interior angles, the ones that add up to 180 degrees. So where C is, there is C here, 6C minus 40 plus this other part where we have C, 2C minus 20 degrees. It is supposed to be equal to 180 degrees. We are talking about what? Co-interior angles. They add up to 180. They are not equal. No, they add up to 180. So we have formed an equation which we are going to use to solve for C. As we can see, we have got C and we also have C. So collect your like terms there. 6 plus 2, that is going to give us 8C. All right, so the reason there, okay, before we talk about this, the reason, these are co-interior angles. Co-interior angles. So remember that co-interior angles add up to 180 since AB is parallel to what? To CD. All right, so like I said, 6 plus 2, that's 8C. Then in terms of the angles, minus 40, minus 20, that was going to give us minus 60, which is equal to 180 degrees. Transpose or take this minus 60 to the other side of the equation. The moment it crosses the equal sign, it becomes a positive there. So meaning to say 8C is equal to what? 180 plus 60. That was going to give you 240 degrees. You divide by 8, you divide by 8. That's obtaining the value of C, which is 30 degrees. So we have the value of C, 30 degrees. So knowing the value of C, we can now determine the value of D because these are vertically opposite angles. Remember, vertically opposite angles are equal. So meaning to say angle D is equal to 6C minus 40 degrees. These are vertically opposite angles. All right, vertically opposite angles are equal. So if D is equal to 6C minus 40, and we have the value of C, just substitute the value of C. We have it, which is 30 degrees in place of C. Put that 30 degrees. 6 times 30, which is 180, and 180 minus 40 is going to give us 140 degrees. So that's the angle D, which is 140 degrees. Also, the whole of this part, it means this is the same as 140 degrees. Vertically opposite angles are equal. So we have our angles there. On question 11, which is you are given 11.1, which two triangles are congruent? Okay, in terms of the presentation, how the angles are given and the sides. This triangle, the first triangle, and the second one, they've got something in similar that we can see. So let's consider like A, B, C. Look, because being congruent, being exactly the same. Look where this G is supposed to be here. This angle is supposed not there, not there. So this one is totally out. We do not have any triangle like that. So A, B, C. Let's say we've got A, B, C. From A to B is the same size as from F to what? From F to E, where we have got the angle E and the angle B being the same. Then from B to C, it is the same. From this B to C, it is the same as E to what? E to D. So these two triangles are the ones that we consider to be congruent. Consider these two. They are saying these ones are similar. This one is for similar to. Remember, similar figures is when one is being enlarged by a certain ratio to another or being reduced by a certain ratio, which is the scale factor. So by what scale factor or ratio is triangle ABC, this one, enlarged to get this triangle? By what ratio? How do you find the ratio? So the ratio that we talk about, or the scale factor, the one that you refer to as the scale factor, it is simply the image side over the object. You divide what you have on the image over the object. So ABC is enlarged to get this one. So it's part of your transformation, which you're not longer using, but this one, they can just ask these simpler ones. So we look into the image over the object, which is complete. So 12 corresponds with X. There's nothing that is complete there. It is unknown. 6 corresponds with Y. We cannot use that because, as you can see, we have got an unknown. 5 corresponds with 15. So we can use that. So this is your object, and this is your image. So 15 divided by 3 can give us what? The scale factor. 15 over 3, which is 3. So the scale factor is the one that you enlarge. You multiply this X by 3 to get a 12. 3 times X must give us a 12. So what is the value of X? You can divide by 3. So X is equal to 4. The enlargement of 3 is the one that multiplied this 6 here to get this value of Y. So 6 times 3 is equal to Y. So 18 is equal to Y. So they can even ask these values of X and Y, which is another part. So here it was just the scale factor, and they're actually asking this, determine the value of X and Y. This is how we just have here the one that I was explaining. From the scale factor, the object, you multiply what is on the object, this one. You multiply this by 3, you must get a 12. 3 times X. X, this one, multiplied by what? The scale factor, it must give us a 12. It's an equation. So you can solve for X. So like I said, yeah, I'm just rushing because it is part of your DOS transformation, which we are not supposed to be actually talking about in this case because they've removed this part of transformation for our 2024 exams, not knowing what's going to happen. And the following, on question 11, for each of the statements below, select the option that is true by writing the letter that corresponds to the correct answer in the space provided. So we are given option A, a square, parallelogram, a kite, a trapezium. Know your properties. Here they're just asking properties of shapes. A shape has two pairs of parallel sides and corners at 90 degrees. The corners being at 90 degrees. Which shape are we talking about? That's a square. From what we are given, it's actually a square. A shape has one pair of parallel sides, one pair. That's a trapezium that you're talking about. Remember, a trapezium, it only has one pair of what? Parallel sides. So if you know the properties of your shape, guys, you're not going to struggle with this. Shape has one pair of opposite angles equal. One pair opposite angles equal. That's a kite. It only has one pair of opposite angles equal. This one pair. So you consider a kite there. Only one diagonal is bisected. It's also a kite. Remember, this diagonal is being bisected by the major one. This one. This diagonal is being bisected. It's a kite again. All four sides are equal on this one. Which one that has got all four sides which are equal? A square. Remember the angles 90, 90, 90, and also the sides are equal. So a square was best option for us to have answered this question that we are given there. All right, there's another part here. Write down the formula for the area of a circle. Remember, area of a circle, pi r squared. Pi r squared. And write down the formula for the area of a triangle, a right-angled triangle, half of the base times the perpendicular height. Half of the base times the perpendicular height. On 12.3, what is the value of circumference over 2 times radius? Okay, they want you to write what is the formula of the circumference. Remember, the circumference of a circle is what? 2 pi r over 2 times the radius over 2 times the radius. So the 2 and the 2 was going to cancel. The radius and the radius was going to cancel. You remain with what? You remain with pi. So what is the value of this? The value was going to be what? A pi. Circumference means what? 2 pi r. But area, pi r squared of a circle. 12.4, use Pythagoras, the rule of Pythagoras to find the diameter of the circle. In this case, this is a right-angled triangle. And thus, this is the diameter. The wall of this line is your diameter. The wall of that line is your diameter, not the radius. The wall of this line, that's the diameter. So from our Pythagoras, the diameter is equal to what? The square root of, remember, the hypotenuse is equal to the square root of the right side squared. 5 squared plus 12 squared. So that's our D, which is the square root of 25 plus 144, which is 169. The square root of 169, which is 13. The 13 centimeters is our diameter, not the radius. It is the diameter that we have there. So you have to correct that part. The radius is the one that you have to obtain. Radius is half of the diameter, which will be 13 over 2. If you want to find that one. Calculate the area of the triangle. The triangle that we are given here is a right-angled triangle, where we understand it's half of the base times the perpendicular height, the ones which meet at 90 degrees, base perpendicular height. This one is not the perpendicular height. So it is half of what? The base. Remember your area. Half of the base times the perpendicular height, which is half of the given base. What is our base? That is 5. And the height is what? The height is 12. So that's half of 5 times 12. So that was going to give us the area. The 6 times 5, which is 30. And that is 30 square centimeters. That's the area. And find the area of the shaded, find the shaded area to 1 decimal place. The shaded area, that is this part which is shaded. As we can see, the part which is shaded, we just have to remove this triangle, this one, from what? From a semicircle. The whole of this part, remember guys, it was what? A semicircle. A semicircle means half of a circle. And we had the diameter, not the radius. It was the diameter, guys. You have to be careful. So you have to correct your memo because they use that as the radius. That is the diameter, that one. The radius is the one that you divide by these 2 into this, which was going to give us 6,5. This is our radius now. So meaning to say we have to use what is the area of this one? It's a semicircle. So it's a half. Remember, area of a circle is supposed to be what? Pi r squared. So it's half of pi r squared. Half of that because it's what? This is radius 6,5. Half of this radius squared, pi r squared. Pi r squared. This half is for a semicircle. It's not a complete circle, it's a semicircle. A complete circle, its area is pi r squared, but a half circle, it is half of that one. Whatever that you're going to have here, you subtract 30, that one of a triangle, because we are saying inside of the semicircle, that is where a triangle was. So we remove this triangle. Thus, we are obtaining the region, which is what? Which is shaded. So just like that, guys. So you simplify this, that was going to give you 36, something like 36,4 to 1 decimal place as our area in square units, which is the square centimeters. So that is how these questions can actually be given, as you just have to revise as much questions as you can. So like I said before, I just had to look into questions which are still part of your syllabus that can be helpful in terms of your revision, which can be helpful. So if you consider this, you can see that we just have to be very careful. A circle, a complete circle, and a half circle, they are 2 different things. The complete circle, it is pi r squared in terms of the area. When it is now a half circle, half of a circle now, when you now consider half of a circle, the area is going to be half of what? What we are used to, half of pi r squared. So we must be very, very careful. And in this case, this one is not the radius. This is the diameter from one point of a circle to the other point. It is the diameter, not the radius. It is the diameter. So guys, let's also try to revise. Let's try to revise as much as we can as we are preparing ourselves for the exams which are ahead of time. Till we meet again.